Hi friends, and we saw MIB contents in our last session. Today we are going to see what is the purpose and the use of MIB and how our smartphones we use in our day-to-day life make use of MIB to acquire minimum essential information to gain access to the system. Let's call this an entry checkpoint, right? Okay, what do you mean by that? When you want to get to a shop, right? First, you need to know whether the shop is open uh, to make any transactions, right? Similarly, here as part of MIP, which is a minimum essential information, which provides the minimum essential information. It is called the minimum system information block. It has a field called cell barred. When it says the cell is barred, that means the cell is not available for the UE to camp on even for emergency calls. It's like the shop door is closed for service, so it's not open yet. Okay, and here I have captured the log packet with a mask 0xb822 for our reference, so that like we understand what it is. It's just a sample with some edits. How do we acquire the minimum system information? So that's something so here you can see a radio frame which is a 10 millisecond, and the half frame is the first 5 millisecond, and the initial as part of initial cell selection procedure, UE assumes that the burst of synchronization signal on the broadcast channel, physical broadcast channel block, is transmitted every 20 millisecond. Okay, so it has a periodicity up to 160 milliseconds, but the initial assumption is going to be 20 milliseconds. Okay, and within the first half frame, this is a 15 kilohertz subcarrier spacing example that we are capturing here, as you can see. So I took a reference for a 15 kilohertz subcarrier spacing, and it's in frequency range 1. Here, in the half frame, it's a 5 millisecond, right? Like it's a first, second, third, fourth, and fifth millisecond. And this call a slot subframe, which is 1 millisecond for a subcarrier spacing of 15 kilohertz. And here the yellow highlighted ones are the SS block locations for a 15 kilohertz subcarrier spacing. It can be present in symbol 2, 3, 4, and 5. That's 4 symbols. And what will be there in those 4 symbols, OFDM symbols, is captured here. Like the green portion with 127 subcarriers is the primary synchronization signal, which can take value of either 0 or 1 or 2. Okay, and the orange one, which is the third symbol here. So the first symbol here is symbol 2. Okay, in this example, if we consider SSB index 0. Okay, in symbol 2 you will have PSS. How do you know that? Like, so in the 3GPP specification 38.211 table 7431, you will have this, but you will be able to find this table. In this, you can see PSS is a primary synchronization signal, and SSS is a secondary synchronization signal, and PBCH is a physical broadcast channel, and DMRS for PBCH is demodulation reference signal for physical broadcast channel. Okay, And the next column represents the OFDM symbol number. Here PSS is symbol 0. So symbol 0 means in the actual radio frame, in the first millisecond for subcarrier spacing of 15 kilohertz, it is symbol 2. Okay? And in symbol 0, from subcarrier 56 to 182, there are 127 subcarriers. That's where PSS is present. Okay? And you can see for the symbol 0, in OFDM symbol 0, you can see 0 until 55. And in symbol 2, 48, 49 until 55, and 183, 184 until 191. Okay, these are the subcarriers that are set to null, and SSS is available in symbol 2, and it is also from 56 to 182 that you can see highlighted in orange color. Okay, you can see here 0 till 55 is blank, and then above from 183 till 239 is blank, which is null. And here in physical broadcast channel, you can see symbol 1 and 3, which is symbol 1 and 3. You will have all the subcarriers 0 until 239 is for physical broadcast channel, and in symbol 2, where we have secondary synchronization signal, we will have 0 to 47, okay, and 192 till 239 we have PBCH, and remaining portion is null. And the DMRS for PBCH is every 4 REs you will have one DMRS, and the position of those DMRS is represented as a quantity V here, and you can see here quantity V in the table is given by V is equal to the physical cell ID mod 4, and the physical cell ID can take values from 0 till 1008. So here, as you see in this log packet, you will be able to find the physical cell ID because you are reading the PSS and SSS. With the PSS and SSS, when you do 3 times the SSS plus PSS, you will get the PCID, physical cell ID. Okay? And then once you know the physical cell ID, and once you decode the PBCH, you will be able to read the MIB contents. Okay, as you read the MIB contents, so these are the information that's present as part of the MIB contents, and MIB is providing the information for SIB1 and also the subcarrier spacing for message 2 and 4. So that's part of subcarrier spacing common here. Okay, and also this is going to tell whether the cell is a standalone cell or a non-standalone cell. So how do we know that? When we read the subcarrier offset, if it takes a value between 0 to 23, right? So it is a cell-defining SSB. So when we say it's a cell-defining SSB, it's a standalone NR 5G cell. As you know from the MIB content that it's a 4-bit information, so you will be able to have, with a 4-bit you can represent from 0 to 15. So how do we know, how do we get the 23 information, right? Like, so then MSB is the most significant bit of the SSB, KSSB, is derived from the PBCH DMRS itself. So that's part of the PBCH. So once we get the fifth bit, then we know whether this MIB is cell-defining, this cell is a cell-defining cell or not. Okay? And how do we know it is non-standalone? When for frequency range 1, if it is greater than 23, then it is a non-standalone 5G cell. And this synchronization signal block need not be located at the center of the carrier frequency, and it follows the NR sync raster with a 1.2 megahertz offset. So what do we learn? So here we already learn about whether we'll be able to access the cell or not. That's whether you can enter into the shop or not for to make any transaction, right? So this is a minimum essential information or the minimum system information, and MIB provides control resource at 0 and search space 0, where we will find remaining minimum system information, which is also called as system information block type 1. Okay, and the subcarrier spacing common tells what is the subcarrier spacing that is used for core set as well as for message 2 and 4. So utilizing that, UE will read the remaining minimum system information, where it will find the P element information and find whether it's a suitable cell to camp on. So it's like an access card to enter into the IT facility or any facility that you want to go walk into, right? So what do we have? Like we have an access card. In our smartphones, we have SIM. It can be physical or eSIM, and it's an integrated circuit card identification number, and it's a unique 18 to 22 digit code that includes the SIM card's country, home network, and the identification number. Hope this video is helpful, and if you want to see more of the videos from me, you can subscribe to this channel, and also you can provide feedback in the comment section, and also if you have any requests on any topic that you want me to cover, so I can look into it and then prioritize that as well. Yeah, let's meet again in our next session. Have a great day.